The conveyor belt is moving downward at 4 meters per second. If the coefficient of static friction between the conveyor and the 15 kilogram package B is μs equals 0.8. Determine the shortest time the belt can stop so that the package does not slide on the belt. Okay, let's see what do we know. We know the initial velocity of the belt, which is also the initial velocity of the block. And he wants the time when the belt stops. So the final velocity of the belt, which is the final velocity also of the block, will be 0, and he wants the time. So we have V naught, and we have V, and he needs the time, so we can use the constant acceleration equation V equals V naught plus AT with two unknowns, the time that he wants and also the acceleration that we need to find. And clearly the acceleration can be found from the force analysis or from the Newton's second law. Now, let's read one more time so we can get the key to solve this problem. Determine the shortest time the belt can stop so that the package does not slide on the belt. So let's look at this from a physical point of view. The block and the belt are moving with 4 meters per second, and if you stopped the belt all of a sudden, which means in a very short time, it means that you stop the belt with a very high deceleration. And naturally, if we do that, the block might slip or slide on top of the belt. But the problem is not asking us to do that. The problem wants the shortest time the belt can stop so that the package does not slide. So we want to reach the maximum static friction before this sliding or slipping happens. And this is the key to solve the problem. He is just saying, please use the shortest time such that this package will not slip on the belt. And by saying that, he just mentioned indirectly, please use the friction force as μs times n, or the maximum static friction. And by doing that, everything else is straightforward. So we have our free body diagram with the weight pointing down vertically. This angle is 30 degrees. So you can see from here, this is 30, and this is also 30, and this becomes also 30. We have the normal, and if this block is going to slide going down, then the friction force must be in the opposite direction. And finally, we can put our acceleration direction. It doesn't matter if you put this going down or going up. We know that it is slowing down, so the acceleration will be in this direction. But if you put it the other way, it doesn't matter at all. The only thing that will change is the sign. We have the summation of forces in this direction. This gives us the normal force, which is going to be equal to the cosine component of the weight. And then we do the summation of forces equals ma along the inclined plane. So we have the friction force, which is μs times n. We have the sine component of the weight in the negative direction. And this is equal to m times a, where we find the value of a. And because we assumed the correct direction, we got the positive answer. And finally, we apply our constant acceleration equation. If we take it positive down, the final velocity is 0, the initial velocity is 4, and my acceleration is minus 1.89 equals to the time, and the time now is 2.11 seconds.